I'm going to show you what happens when the Earth decides to move. An earthquake isn't just shaking, it's the planet releasing energy that's been building for decades, sometimes centuries. And in the next 3 minutes, you'll understand exactly how these forces reshape everything we know. So what actually happens underground? When rock finally breaks along a fault, it sends out 3 types of waves. Primary waves compress and expand the rock like a slinky. They're fast, arriving first. Shear waves move perpendicular, shaking side to side, and they're the ones that make buildings sway. Then surface waves roll along the top like ocean swells, and these cause the most damage. They turn solid ground into something that behaves almost like liquid, a process called liquefaction, where buildings simply sink. When a fault slips, one side can jump up while the other drops down, sometimes by meters in a single event. This is how mountains grow and valleys form over millions of years. And in subduction zones, where one plate dives beneath another, the ocean floor can suddenly lift, displacing massive amounts of water. That's your tsunami trigger right there. But the shaking is just the beginning. Earthquakes set off a cascade of secondary disasters that can be just as deadly. Hillsides collapse in landslides, sending thousands of tons of rock downward. Soil that seemed stable liquefies, swallowing roads and buildings. Infrastructure fails. Water mains burst. Gas lines rupture. Bridges collapse. Rivers change course. New springs emerge. And existing geysers can alter their eruption patterns. The earthquake rewrites the hydrology of entire regions. After the shaking stops, the real work begins. Ecosystems have to adapt. Forests on new slopes, rivers in new channels, animal habitats disrupted, but humans are resilient. Cities rebuild with better building codes, flexible structures that can absorb the energy, and reinforced lifelines like water and power systems. We learn from each event. So how do we read the planet's pulse? Seismometers scattered across the globe detect every tremor, measuring magnitude and intensity. We map faults, identifying which ones are overdue. Early warning systems now give us seconds to minutes before the waves arrive. Enough time to stop trains, shut down reactors, and take cover. We practice drills, prepare emergency kits, and design our cities to survive. Earthquakes affect the Earth by releasing stored energy that reshapes landscapes, triggers cascading hazards, and tests our ability to adapt. But with understanding and preparation, we turn destruction into resilience.